Hi, I'm Matt with Schematical, and today we are talking about virtual private clouds and the Terraform scripts I've designed to go along with them. And this is kind of the fundamental building block because everything else runs inside of a VPC. So this is a very important one. So if you're interested in booting up your own AWS infrastructure, and maybe you're new to AWS, maybe you're not, but you're trying to get on infrastructure as code and use Terraform to standardize everything so it's really scalable and easy to control and put into version control, Terraform is for you. And I have a bunch of scripts I'd like to share with you so you can boot up your infrastructure quick and make it so it scales very fast, very quickly, or scale down because this AI tech bubble can only last for so long. So we'll get into that one more later. So let's start with a brief definition of what an Amazon virtual private cloud is for those of you guys that do not know. What is a VPC? Well, it's an Amazon virtual private cloud. On the left there, we've got the public internet, and on the right, we've got our virtual private cloud. AWS has a bunch of regions, big facilities where they host servers from, booted up all over the country, Virginia, Ohio, etc. In these facilities, they have different availability zones. Availability zones are basically a collection of bunkers that allow us to have some redundancy. So, for example, in North Virginia, here we've got two availability zones. So, in case availability zone A goes down, B will still be able to handle the traffic. Inside each availability zone, you can have multiple subnets. Subnets are a way of grouping resources that need network internet access. You can boot up servers that run on these subnets, and they can access the internet via an internet gateway. That way, traffic can go out and come back in. But what we don't want is malicious traffic making its way in to bombard our servers or otherwise try and hack them. So we'll boot up a second set of subnets in each availability zone called private subnet. This is where we will boot up our servers that we don't want the entire internet to have direct access to. In order for those to reach out, though, and call out to the internet, perhaps to access some third party API, they need a NAT gateway. So our servers will reach out to the NAT gateway. That'll go through the internet gateway, and that'll make its way out to the public internet. The last piece of the puzzle is the route table. The route table acts as sort of the old Yellow Pages book. This tells us what IP addresses are for local stuff versus for reaching out to the NAT gateway and helps direct traffic accordingly. So that's AWS VPC in a nutshell. All right, now that we've got that out of the way, let's dig into my scripts here. So if you're trying to navigate to the VPC, you can just go ahead and search VPC here. And this will give you a list of your virtual private clouds, as well as all your subnets. So we can see here we've got one called dev, and we can see it's got a CIDR of 10.0.0.0/16. And this is a new feature here. So I don't use the console as a ton except for retrieving information more. So this is a fun one though. You can see that I've got two subnets, private and public. And these are booted up directly from the scripts I'm about to show you. You've got your route tables right here. Your public route table is different from your private route table because they have to map to different spots. So for example, you've got a route to that NAT gateway from your private and the internet gateway from your public there. Let's take a look at the private subnets here. So the private subnets for this are all associated with dev, and that the two private ones would be where I boot up all my server-side resources, databases, the application layer, perhaps, not the load balancers, because those have to reach out publicly, but a bunch of things that I don't want the rest of the internet to be able to talk to. Because remember, there's three layers of security. I think I've talked about this before, but one is the database password, for example, and username, which can be brute forced given enough time. The second one is the firewall or the security groups, as we call it here in AWS. And the third one is this VPC type subnet setup where network requests can't even hit your database without going through some other environment that you can control, like your Bastion. Let's take a look at the route table here. So the route tables are pretty simple. Anything except this is going out to that NAT there. And I guess I've got a VPC peered here. Oh, it's for S3. I forgot. I've got S3 mounted here. The endpoints allow you to basically expose direct HTTP or network flow traffic stuff to the VPC. So that way we can just basically get quicker access to S3 here. By the way, the UI for the AWS console almost always changes. So that's why I prefer to stick with their standards for things like Terraform. This doesn't change all that often. It's pretty cut and dry. It's designed that way so it can be backwards compatible, forwards compatible. Not to say that there will never be breaking changes, but if I do a video on the UI, it'll change tomorrow. I guarantee you that. Right now, we're going to be looking at the SC Terraform model. I'm sure the link will be in the show notes here. Otherwise it'll be at github.com/schematical/sc-terraform. And we're going to go into modules and VPC. Now, I should note that I may split these out into separate modules. And so in the future, just go ahead and make sure you're looking for the Terraform VPC module. That's what we're talking about here. So the variables you're going to put in is the VPC name. Now, this can be dev, this can be staging, this can be dev 01, this could be dev v1, whatever you want. You can have as many VPCs as you want. Typically, it depends on how big the client is. I've had clients where they have different AWS accounts for every single environment. That's how big they are. And they're all kind of grouped together. So it means each AWS account has its own IAM users for each environment. So you can have IAM users that can't even log into production that are on staging. So that's a really big client example. A medium-sized client would probably have at minimum different VPCs for each environment. So that way you don't have accidentally dev requests somehow getting routed to prod databases. That'd be real bad. And the small ones, like what I'm going to show you now, they have one VPC that they share for all the environments, and we use the other tools such as the security layer number 1, username and password, and security layer number 2, such as firewall, security group rules to isolate them. VPCs do have internet gateways that are on and costing you money, NAT gateways that are charging you per, I believe it's gigabyte. And so we want to make sure that we are, picking the solution that's best for you. Now, what you really want is a modular system like this, or if you needed to expand your production and say you wanted to you had all your environments in one VPC and you wanted to switch that out, this plug and play system right here that I'm working on is real nice for that. You could just say, okay, I'm going to change the Terraform. I'm going to boot up a new production in a different VPC, and there you go. In reality, you probably have to migrate some databases, but it minimizes downtime and makes it so you can scale up as easily as possible. So let's keep moving on. So you have to pick a region, the AWS region you'll be booted up in. That's up to you based on where your clients are. VPC CIDR ID, if you're not doing a peering with another VPC, then I wouldn't worry about this so much. But I see a lot of times like 10.1, 10.2, 10. So that way, if you need to peer, they have their own CIDR blocks there. If you're not familiar with CIDR blocks, they're a bit beyond the scope of this video. I'm sure there's plenty of good YouTube videos on that. But basically, IP address ranges that your VPC will have reserved for your resources. If you're not familiar with what a bastion is a way to access the private resources running on your private subnets while preventing them from accessing public traffic. The bastion uses a SSH tunneling system. So that way you have to tunnel through the bastion in order to access those, makes it much more secure. And additionally, here at this next one, we use firewalls to restrict who can even hit the bastion so no one can brute force the bastion. And so this is a key pair you boot up in the EC2 section of the AWS console. You should be able to see that in there. Boot that up, create one, download it once, and make sure you have that handy when you go to access your bastion and tunnel through it. Private subnets here. This is a list of private subnets. So by default, I've got it for private US East 1A. If you don't change this, and US East 1B. In reality, if you're bigger, then I would consider more subnets. The project I've got running on this one is drawnby.ai and some other schematical resources. 9.99.9999999 uptime is not necessary for those yet. But if I had a bigger client, or I do have some that they go down, they lose $100,000 an hour. Yeah, we got a lot more than 2 subnets there. A lot more than 2 availability zones. We don't risk it. But that's up to you. Again, these are designed to fit your budget, fit your amount of uptime that's required for your project. Same thing with public subnets here. I'd recommend making sure you have the same amount of public subnets as private. Is it necessary? No. You could create a subnet specifically for batch jobs or something of that nature if you were inclined to. Nothing's going to stop you. This could work with that. Yeah, this should work with that. Got that. And then these are just tags. They're just used to organize stuff in AWS. They have no real functional. So let's look at the main section of this. And I am likely to reorganize this in the near future, but for now, this is just our provider, which is the AWS provider. The versions will update as time goes on. First thing we're going to boot up is a VPC, which is actually has the name that we gave it and the CIDR block we gave it, and just some basic stuff. We're going to have a NAT gateway, and again, that's what allows the private subnets to talk to the public subnets that talk to the internet gateway that talks to the rest of the internets. We're going to have an AWS NAT gateway here. That's the Elastic IP. Sorry, this is the Elastic IP for the NAT gateway. This is the NAT gateway itself. This is the subnet that it's going to be associated to by default, but in reality, the route table will associate it with all the subnets, and this will associate it with that Elastic IP there. And here's our AWS Internet Gateway, which will talk to the rest of the world. Here is our first subnet. Actually, this is the private subnets. We're going to do a for each there and iterate through those. It's going to use the CIDR block. You set it. It's going to assign it to the main VPC ID that we've got up there at the top. It'll decide what availability zone to stick it into right there and some tags. And here's the same thing for public subnets and an AWS route table association. So this takes a route table, which we haven't defined yet, that's coming down here, and associates that with, this is the public route table, with the public subnets right there. And again, for each public subnets. And the same thing with the private right there. And again, there's a public route table, private route table, and then we have to have our rules. So there's an AWS route that associates with our public route internet gateway, and this one does the private route NAT. This attaches the internet gateway to the VPC, so that means it's available to it. And here's our S3 endpoint that I got turned around a little bit on earlier. I forgot about that. You can add as many of these to this as you want. Outside of this module, you can just attach those if you have other services. And if you really want me to edit it so there's more services by default in this, leave a comment or jump on the Discord and bug me, and I will do my best to help you out. AWS VPC endpoint route table. Okay, this associates the route table with the VPC endpoint. And here's our bastion. And we'll boot up one only if you put in a bastion key name. If you leave that as a blank string, the number will be 0. So it won't bother with a bastion, save you whatever a T2 Nano costs, which is very affordable, very small. There is a new way of creating that bastion effect without having an always on instance. I do not have that wired in here yet. I need to research that further. I have used it for another project, but it was manually set up. And here are your security groups for the bastion, which we will boot up either way. There's no extra cost to it. And it has your ingress rule in there, but allows you to talk to everything once you get in there. So I should probably delete that one or make an IPv6 rule. I'll get that figured out. And what's it output? All right, so it outputs the VPC ID here, private subnet mappings, and the public subnet mappings, because a lot of other resources in this are going to need to know about the public and private subnet mappings. And so we can boot up resources on those. It also outputs the Bastion security group, so you can have other resources whitelist that as an ingress thing. So it allows that to talk to your database or your other EC2 instances, etc. It did just occur to me, almost in post-production here, that I should show you how I use this VPC in an actual setup here. There's a couple different ways you can do it. You can give each environment its own workspace. The project I have here to demo for you right now is too small for me to even really worry about that. So I have multiple workspaces, I have multiple environments defined in a single workspace, which I wouldn't recommend for a very big customer, but for a customer our size, for this little project, I'm not going to worry about it. So here is the main script for that. You can see I've got basic Terraform using S3 as a backend there. And if you have questions about this, I can do other videos about them. So feel free to ask questions. There are plenty of good videos on this. I don't want to reinvent the wheel, so I'm just going to go fast here. Here I'm booting up an AWS REST API, which is basically proxies all the different environments, their different specific spots. We have just a basic S3 bucket we share for the code bucket store all over. IAM role, and here's the VPC. So it's simple as this. We give it a VPC name of dev, which is actually our general one for all the different projects here. And we reference it by source. I'm going to do a video in a little bit about referencing them specifically with versions and version control, but I don't have that up yet. I'm going to pass it in the Bastion key pair name, which is one I've had around here that I created for this. You can see here I defined two different environments. Okay, this is an API gateway environment, so it's specific to API gateway here, one for dev, one for prod. It handles all the routes. I'll do another video on that later. But the more important part is here is I define locals, and you can see I'm creating dev local environment variables for a lot of the dev stuff we just booted up right there. And then that will get passed into the different projects with their respective ones. So again, one's Chaos Pixel, which you probably know better is drawn by AI. If you've been following the channel, Chaos Pixel is the back end for it. And I'm passing it that environment info, and that includes the VPC information there. And the same thing for the front end drawn by AI also needs a lot of that information that's in here, like the host ARN. Yeah, that's how you would actually use it in reality. And again, this is currently in the SC Terraform module as of August 7th, 2023, when I'm recording this. So that is our AWS AWS VPC in a nutshell. Oh yeah, I forgot that that's even on the board behind me. Wow, I am a nerd for this stuff. So yeah, that's it. I designed these scripts so anybody, my clients or anybody on the web, can use them to build scalable web applications, primarily on Amazon, but I'm going to dabble with other things, and use infrastructure as code right out of the box to very much keep your infrastructure in lockdown and avoid that drift that happens if you click around the console and change things. And now all of a sudden you're like, wait a second, why did this person do that? Who did this on what day? Infrastructure as code, really nice. If you're looking to use these modules, they're free on GitHub right now, open source, have fun. If you need help with them, jump on the Discord. I also do a group coaching. So if you want a little more hands-on, hop on my group coaching. I'm sure there'll be a link in the README there. If not, it'll be at schematical.com. Additionally, I do consult on this stuff. So if you are a larger company that needs a lot of help, I do consult on these things. So please reach out to me again via schematical.com. If there's anything, any questions you've got, feel free to leave a comment. If there's modules you want that I haven't covered yet, please feel free to ask about them. This is kind of the fundamental building block because everything else runs inside of a VPC. So this is a very important one. More videos to come soon. So thank you very much. And without further ado, I'm Matt with Schematical. Have a great day. Someday I'll come up with a sign-off line. Someday.